In this section, we're going to talk about a little bit of vocabulary. We're going to get ourselves set up for Chapter 7, and then we're going to hit the ground running. Um, but the big idea from here is sample spaces and events. These are the big takeaways. But what I've broken down in a little more specifics is ideas just into four big bullet points: sample spaces, events, and then as a little minor note, we've used set notation before, so now we're going to use set notation to describe sample spaces. And then last but not least, we need to catch on to this vocabulary word of mutually exclusive events. So keep your ears perked for all four of those things throughout this lesson. Okay, so starting off, if I just were to ask you, what are all the different outcomes when rolling one six-sided die? And then can you write them as a set? So do you remember how to do that using the tools from chapter 6.1, I believe, or set notation, whatever your book, whatever section is in your book, because different people might be using different books. But long story short, just can you rate them as a set? You guys remember? Okay, well, so if we have a set, we're going to have a little brace. And I say, what are all the different outcomes of rolling a six-sided die? Well, it's 1, 2, 3, 4, 5, 6. Those are my outcomes because I could either get a 1, a 2, a 3, a 4, a 5, or a 6. Right? And if you wanted to give it a name, you could. You maybe call it like D equals or something like that. And there you go. That done. By the way, this is called a sample space. So what a sample space is a set that contains all of the possible elements. So the question is how is this different than a universal set? Then how is this different than what we learned in the previous chapter about universal sets? And it's a very simple answer. It's not. It's the same thing. Um, uh, uh, Somebody in mathematics will argue that there is a slight difference between the two. Somebody who's involved in really doing sets and number theory and whatnot. But for our purposes, for our level of mathematics, same thing. Doesn't matter. So if you remember what universal sets were, then sample spaces, just put them in your head. Same thing. So if they start talking sample space, it just means every possible element listed out. All right. So now let's practice this. So practice writing sample spaces, flipping a coin. Now, we will always assume a coin will land with either its heads or tails face up. We're going to make the assumption it will not land on its side and we're going to get a rim or whatever. I had one student once adamant about that there's really three possibilities. No. All right, heads, tails, that's it. Okay. Write the sample space for flipping one coin. All right, try it. Okay, hopefully you were able to do this, or you just said, "Wow, I'm not even going to bother trying it because I got this." What is the possible events? Well, you can either get a heads or a tails, right? Now, how would I write a sample space for flipping two distinguishable coins? Hmm. Well, that means I could do what? Well, I could either get a heads and a heads and a tails and a heads, and a tails and a tails. And the key thing to point out here is you want to make sure you're understanding that these are two different events. It's not because it's first and second. That's not what's going on here. The idea is that the coins are distinguishable. So think of it more as the first number that we're writing here, the first letter, the first whatever we're writing on the stuff on the left maybe is a penny, and then the one on the right is maybe a nickel. So therefore, you can totally tell the difference between a heads and a tails versus a tails and a heads, because the one on the left is describing the face of the penny, the one on the right is describing the face of the nickel. Okay, so two totally different things. All right, now I want you to try this one. Good luck. Three distinguishable coins. Might get a little bit long, but you could totally do it. All right, pause the video, give it a shot. Okay, here we go. Heads, 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 tails, heads, tails, heads, tails, heads, 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 tails, 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 heads, tails, um, tails, tails, heads, and tails, tails, tails. Okay, the reason I wanted to do that was I wanted to point out how I make my list, which is I do a pattern. I make a pattern. I start off by saying, what is all the ways I could have three heads? All right, there's only one way I could do that. I could have heads, heads, then heads. Then, what are all the ways I could have two heads? So heads, heads, then my third one could be tails, or a heads, tails, heads, or my second one could be a tails, and so on and so forth. And that way I can have a better chance of not missing something. Still, it's always possible that you might forget something, but good chance not going to happen. Okay, so now let's do. That's it for sample spaces. Right, we got practice. You're just writing out every possible event. And yay, lots of writing. Okay, events. Sorry, not every possible event. Every possible element. Okay, because now we're going to move on to events. Now we're going to move on to events. The event is, well, here we go. Write the set that describes flipping three distinguishable coins. Zoop. Okay, which we already did. Where at most one tails is flipped. All right, at most. What does the word at most mean? Sometimes if you get to a problem and you're wondering, I always say put it in another context. Say like I could have at most one speeding ticket. Right? What does that mean? And sometimes just putting a different context really opens up the meaning for you. So if it says I could have at most one speeding ticket, then that means one or less. If I have more than one, if I have more than one, then I will lose my driver's license or something. I don't know. But the idea here is at most one tails. Okay, so from above, from what we just did, in my set here, um, that E just doesn't want to happen. Okay, in my set here, I'm going to look at all the different elements that have at most one tail. So I could have heads, heads, heads. Keep that one, right? I can keep heads, heads, tails because it has one. Heads, tails, heads, or tails, heads, heads. Everything other than that, all the other options, all the other elements, all have two tails or more, and I can't have those. So therefore, there is my set that has at most one tails. Does this seem familiar? Think back to chapter 6. If you were going to talk about this from chapter 6, what would you call this? Right? You would call this a subset, right? Because all of these elements are contained in the sample space. So, what is an event? It's just a subset. There's nothing new there. So subsets are events. So the only difference is when we talk about events, they're just going to be more like kind of real world things, and we're working our way towards the concept of probability. So we're going to say, what is the probability of flipping, yeah, at most one tails when I play this game? And so it's just kind of more natural to refer to them as events, but really same thing, same concept, nothing new. Okay, so let's keep moving here. I think this is going to be one more example, and then we will take a break, and then we'll pick it up on the next video. So last example here, I think. Write the set describing the event that exactly one die is even. One die is even when rolling two distinguishable dice. Okay, can you do that? So try to get yourself through all the vocabulary. That's the hard part. Okay, pause the video, give it a shot. Okay, so here we go. Write the set describing the event that exactly one die is even when rolling two distinguishable die. All right, well, that means if one die is going to be even, I'm going to guarantee, I'll just kind of go through this and say, okay, I could have and the key is it's exactly one die, so they both can't be even, just one of them. So that means I can get a 2 and a 1, a 2 and a 3, a 2 and a 5, and that's it if I roll a 2 first. Okay, but I could also go the other way. I could get a 1 and a 2, a 3 and a 2, or a 5 and a 2. Right? So, and then this would be every possible option if I had a 2. So now what's another even number I could have? Well, I could have a 4. So I could have a 4 and a 1, a 4 and a 3, 4 and a 5, a 1 and a 4, a 3 and a 4, a 5 and a 4. And I think you are already ahead of me now. If you weren't with me at the very beginning, I think you got it now. We are going to, there we go, do the exact same thing for a 6. 6 and a 1, 6 and a 3, 6 and a 5, 1 and a 6, 3 and a 6, 5 and a 6. And there we go. And you can call this one whatever you want. I'll call it E for even, I don't know. So, are you getting the idea? I hope you are. So now, that's pretty much it for sample spaces and events, and that's kind of like the big idea from this section. So the rest of it's going to just be a little bit of writing using set notation. Instead of writing them out actually as sets, we're going to write using set notation, and we're going to go on to mutually exclusive events in the next video. All right, we'll see you then.